So the algebra of functions is section 7.4, and what we mean when we say that is the sum, difference, product, or quotient of two functions or more functions. Okay, so adding, subtracting, multiplying, and dividing. So what the rule is that as long as x is in the domain of both f and g, I can add the two functions together. So f plus g of x, f of x, plus g of x. That was a plus. Okay. F minus g of x I can get by doing f of x minus g of x. F times g of x, so here's our product. So f of x times g of x. And for the quotient, again, you just divide the two functions. Okay, we'll have a further restriction that g of x can't be 0 for doing quotient, but that's the only thing. Okay, so what we're doing is that as long as you start with two functions fitting the function criteria, if you add, subtract, multiply, or divide them, what comes out is itself a function, meets that same criteria. So if you start with two functions and you add them, subtract them, multiply them, divide them, what you get as an output is also a function. Okay, so the domain of the combo is the overlap of the individual functions' domains. Okay, and then again, making any further exclusions you have to if you're dividing so that you don't divide by 0. Right? No division by 0. Okay, so let's practice. So here I have f of x. It is x squared plus 7, and I have g of x, 6 minus 4x. And I want you to find f plus g of 2. So if it's f plus g of 2, that's the same thing as f of 2 plus g of 2. Okay. So f of 2, right, we come up to f and we plug 2 in. So we'll get 4 plus 7, that's 11. And g of 2, I have, so now right, I'm on this part. So g of 2 is 6 minus 4 times 2, 6 minus 8, so negative 2. So I have 11 plus a negative 2. 11 minus 2 is 9. Okay. So f plus g of 2, I just find f of 2 and I find g of 2 and I add them together. It's just that easy. F minus g of x. Now this one gets a little trickier. So f of x minus g of x. I don't have a number to plug in. Okay, so what I'm going to do is I just take f of x, so I'm going to copy it down, x squared plus 7, and then I'm subtracting off g of x. Now g of x, you'll notice, has more than one part, and I'm subtracting it. So I'm going to be careful and wrap it in some parentheses so that I don't make the mistake of not subtracting both parts. So I'm going to do a little tidying here. So x squared plus 7, remember I changed the signs of everybody inside, so minus 6 plus 4x. And then one last step just to tidy. So my final answer here would be x squared, I'm going to go ahead and put it in standard form because I can, plus 4x, and I have 7 minus 6, so plus 1. That is the answer when I'm asked to find f minus g of x. It's this expression right here. Okay. One thing I want to point out before we get any farther, and I could have said this back in 7.1, notice when what's after the functions is a number, your answer is a number. If what follows your function is a letter, your answer typically is a set of letters. Okay? Okay, so state the domain of f over g of x. Well, let's figure out what the overlap is just for the given functions. So f of x equals x squared plus 7. So this, right, is it a fraction? Nope. Is it a square root? Nope. So the domain is all real numbers. Okay. G of x is a linear function. Do you recognize it there? So its domain is also all real numbers. So the overlap is all real numbers. Okay, so then the only thing I have to be careful of is not dividing by 0. So it's all real numbers except for whatever makes the denominator 0. So doing a little algebra there. What do we get? X equals 6/4, 3/2. This is the one we have to exclude. Everything else is fine. So set of all x's such that x is not 3/2. And I just wrote it that way because it was easiest to fit in. Interval notation would be just fine. Okay, I didn't have very many notes for this because it's, like I said, it's pretty intuitive. So maybe we'll add a few more on at the bottom here, but if you want to practice this. So I have two new functions. I have p of x and I have q of x. First thing I ask you to do is, this is our multiplication, so p times q of 1. Right, so we find p of 1, we find q of 1, and we multiply them, just like that. Right, so p of 1 what is that? 4 over, put an arrow here because I'm not exactly equal anymore. I'm just looking at p of 1 right now. 4 over negative 2, so that part there is negative 2. Q of 1 is 2 times 1 minus 1. That's 1. And then I multiply these two together. Negative 2 times 1. Here's my answer. Negative 2. Okay. And then, question 2, p of 2 minus q of 2. So p of 2, I'll write it a little differently this time. P of 2, 4 over 2 minus 3, 4 over negative 1. So that's negative 4. And q of 2, what's that going to be? 2 times 2 minus 1. 4 minus 1 is 3. Okay, so now I know p of 2, and I have q of 2, so I need the difference. So negative 4 minus 3, negative 7, right, is that answer. Okay. Now the last thing, state the domain of p over q of x. So this is a little bit different. So p comes in with its own restriction. Right? So there's a number that we cannot use in p, and that is, so if I just write domain of p, set of all x's such that x is not 3. Okay, so p already has that kind of baggage along with it. 3 is not allowed in p, so it can't be in any combination that includes p. Okay, so 3 is not allowed any place near p. And now, since we're going to divide by q, we're going to have one more restriction. We're going to have to exclude anything that makes the denominator equal to 0. So it looks like 1/2 also has to be excluded when we're doing the quotient. Okay, so x actually cannot be equal to 1/2. So the domain of the quotient, p over q, is, let's see, how about the set of all x's such that x is not 1/2 and x is not 3. Okay, the algebra of functions.